My name is Shahar Binyamin. I'm co-founder of Inigo, where we help companies gain control of their GraphQL APIs. What Inigo is an agnostic layer that hooks up to GraphQL servers and give them any GraphQL server, completely agnostic, and gives a whole set of control and management tools around GraphQL. So this talk is about security. And probably asking yourself maybe you're asking yourself, what is there to secure? So last time I gave this talk to CISOs, I asked who knows if their organizations are using GraphQL. So I'll actually ask a different question here. Who here put GraphQL in production and had a security review? Show of hands. Good. Low numbers. Maybe you can help me during this talk and see what they ask you, what they poked you, and what was interesting, and what gaps you had to do. So I'm going to cover concepts, approaches, try to keep it high level, and talk about a few things that we think are critical when you're ready to put GraphQL in production at scale in maybe an organization that needs compliance and governance, and maybe not. Usually, this GraphQL starts with one champion. This is a developer-driven technology. There's a developer out there. He or she got super excited about GraphQL. Most likely, they worked on GraphQL in a different company and brought it to the organization. And now we have a champion, and that champions are going to get going. And most likely, it will start with one implementation of GraphQL server. Maybe it's a pet project, small project, new feature, REST replacement, being the first GraphQL implementation of the org, like exploration. And then it grows. And as you and your team continue to grow, the graph grows with you. You might evolve to a federated situation. You might not. Multiple teams are going to get involved either way. So now you feel comfortable with this. The team feel comfortable with this. We have GraphQL APIs connected to the database. We have the best programming language. We have the best GraphQL server. Let's go. Let's go. But just like any new technology, GraphQL brings a lot of new challenges, and a lot of areas where it's worth to have a discussion before we productize and operate them. And that moment that caused the trigger point is where the platform team or the DevOps team is asked to own the operability of the graph or the gateway if you move to a federated environment. And they're being asked to do this without control, without visibility, and with no governance tool of how the API is going to be used. And the challenges really start at that moment, in that handover, if you are in a large organization. There is unclear ownership between the GraphQL owner, the developer, and those platform DevOps, maybe Sec DevOps are involved, about what is the next steps and who carry what responsibility. And you've been here, you've used GraphQL. There's a lot of amazing talks here about how to create supportive tools for developers. There is a gap in both tool and educations on what does it mean to productize this in an enterprise environment. And we start thinking or raise questions about how should think about introspection? How should I think about DOS attacks? Can someone overload my system? These are just like common questions that now more people are involved, more people with different hats are challenging the fact that, like, what does it mean to put GraphQL there? And you might even push back and say, I don't need to even have this conversation. Most of you did not raise the hand when I asked if you had a security review because you say, hey, I have a WAF. I have an API security gateway. It's amazing. What is there really to secure there? So let's tackle this. Let's go into this, and let's identify this gap that GraphQL is introducing that exist between classic API security gateways and your classic even monitoring tools. The reason to pay attention here is let's use Kubernetes as an example. When Kubernetes, another developer-driven technology that was brought in by the developer into the organization, it brought in, said, let's productize this. And then the DevOps, in this case, not the platform team, were saying, hey, what is this? How do I operate this? I don't know what to do here. And then 2 minutes later, the security team comes in and say, how do we secure this? So we are at this phase of GraphQL adoption. We're moving from developer adoption to enterprise adoption. And now the platform, API teams, every company calls that team a little differently, are getting involved. And those teams are looking for answers. And they're looking for help. And down the road, the security team will start being aware. Because security team today are in this discovery phase. Do I have GraphQL? They don't know. The CISO doesn't know. And that puts a lot of pressure on the developers to be forced to put a security hat and tackle questions maybe arguable or not part of their day-to-day responsibility and job. And if you continue, if all of us continue to rely on existing WAFs and existing API security gateway, the reality is that they are not up for the task. So what we did, we took a step back and said, let's see what's out there. We spent last year and we continue earlier this year to look at CVEs about GraphQL. We looked at all HackerOne reports when it comes to GraphQL, and we analyzed them to see how attackers leverage this new GraphQL endpoint in new ways and how they find ways to abuse them. So this is based on the MITRE, I don't know how to pronounce it, CVE, and again, HackerOne, where bounties range from a few tens of dollars to up to $20,000. And this is very interesting because usually in HackerOne, you don't see a lot of DOS attacks. You don't want to encourage hackers to DOS your system. You want to see a lot of access control shenanigans. And still seeing almost 70% of them being abused and DOS, that is pretty high. So still not a bit skewed, but these attacks are out there. And they're happening, and your secretly protected GraphQL API is now a target. And more pen testers are being educated and being learned about the fact how they can take advantage of GraphQL APIs. Or I would say GraphQL API, because it's one endpoint. So when we embrace this concept of a free-form nature API, we open the door to a whole new paradigm of attack surfaces and vulnerabilities. So let's again, I'm staying very high here. Standard API don't look at these things. They are mostly looking at the HTTP call. And the traffic that goes both in the request and the responses are just a blind spot. Not only for the analytics team, for the platform team, but also the security team. What if, so let's dive into some of them. The reality is like one GraphQL call that is abusive will most likely is able to bypass existing WAF security that you have. So what do hackers do? How do they know? How do they know I have a GraphQL endpoint? It's not that hard. Only takes one curl call. I send one curl call. You can have introspection disabled. You can have all the protection that you might think that you need. But since the typical response is always 200, and it's always in JSON, and will include some data and errors, and you might try to hide it. Oh, it's not going to be /GraphQL. I'm going to do /query. That will work, right? That will hide everyone. No. They will just try any one of those endpoints. They will see what your web client is doing, and they will find that endpoint. That's it. That is the start. This is step one, detecting that endpoint. And this method can be obviously automated and run on various companies against multiple endpoints, all in parallel. So this is a matter of seconds. And now they get the response. So the second step to do is how do they fingerprint what GraphQL server you're using. And I'll tell you in a second why it's important. But based on the response, based on the syntax, not only is it possible to detect what GraphQL server you're using, sometimes you can also see what version it is. And it gives a lot of power and control to the ones who are trying to find vulnerabilities in your API. This is an example how the different implementations of GraphQL have different weaknesses. Because the reality is that the communities around each one of these open source implementations are different in size, in how active they are, and abusers knows that and take this into their advantage. So they know how to detect, to fingerprint, and can have now steps that they know that will work against your GraphQL implementation. So you probably, I'm sure all of you, by the way, someone told me to be funny, so let's assume all of this happens to someone else, not us. It's other people's GraphQL API, they're unsecured. We got this. So often, you probably very security-minded, you looked in Google, GraphQL security, boom, depth, height, introspection. This is what comes up. This is what people are talking about. This is the tip of the iceberg. This is almost nothing. If you only took care of these 3 checkboxes, there's more work to do. And I'll give an example that often hits in the right spot. What happened? Now, each one of you imagine your own GraphQL implementation. What happened if I'm going to send one query with 1,000 directives? What will happen to the parser? What will happen if I do the same with 10,000 directives? What will happen if I do this 100 times? Your parser most likely is going to go bananas. And this is a classic DOS attack without your business logic even knowing what is happening. Simple. So we have to start thinking about more than just those 3 bullets that is often too easy to talk about. So when you think about a line of this, just a few more examples here. So when you're thinking about like the first line of defense, it's critical to just put the right guardrails in place. And these are like very common examples that we've seen, which take advantage against the spec. Not even your own implementation. We don't even care if you use monolith or federated graph or something. It doesn't matter. This is attacking the spec. So the first line of defense is this what we call query protection, how we can protect against like this type of DOS attacks, that circular fragments, nested fragments, a lot of kind of fun things to do if you're the hacker, but not as fun if you're on the other side. Especially those platform teams, those DevOps teams that at the end of the day are responsible for this too. If they have an SLA, if it's, I don't know what, they're responsible for this. So their job is on the line. And also with GraphQL, again, free-form nature, every field that can have a value to it, if it's alias's name, if it's the operation name, it's variables, all of them are now new surfaces for injections attack. So think about everything you know about Rust, and now just add a multiplier. So this is the first line of defense. Second line of defense, for us, then concepts, happy to be challenged about everything here, rate limiting is another great example where your WAF is falling short. WAF today are counting HTTP calls. Not enough. What they should be doing is start counting operations and go much deeper into the intent of each one of those operations. I'll give you a second to look at this pretty cool GIF. So rate limiting is actually 2 different things. First one is inbound. I'm not going to talk about all those ways to think about pre-predict the complexity of the query. This is different ways. This is how we think is a little more robust. So the first way is to think about the inbound operations. Let's start counting how many login attempts are happening. Let's start counting how many mutations are being called. not just the number of API calls. Because in this example, we have a few hundreds login attempts, simple brute force against login, which counts as one HTTP call. So we need to protect this. Another example where this is a little more painful is that you have a field that is heavy. It's just heavy to response. Maybe it's the user balance, how much money they have in the account. And maybe it's a dynamic field that costs us a lot to generate, to response. Intentionally or not intentionally, someone is calling that field a lot. And now we have data resource exhaustion. All of us are, like all the database, all the business logic is very focused on to return this overwhelming request of one field. That's one side. The other side of rate limiting is to think about what is being returned. If you're worried about data scraping, if you're worried about, again, someone taking advantage of some fields that are more expensive than others, let's start counting how many objects have been returned to this specific user. And that way, you can put guardrail and say, hey, you have been asking too much information, although it's one call or two call or three call in the last minute. Let's put some controls around that. In this example, someone is trying to gain access. They have access, they have a user ID, they have a password token, whatever, but they're just like scraping the data undetected because this is an authenticated user. So let's be smarter about this and start thinking about how much data did we return and how much did it cost us to do this. That's level 1. How can we do this better? Let's bundle our RBAC into GraphQL. I have anonymous users, regular users, super users, admin. Let's give different allocation to different roles. So we're not being smart about how we're thinking about rate limiting and how much bandwidth we're giving different role. That sounds pretty cool. How can we make this a little better? How about we figure out some fields are more expensive than others and say that balance, total balance is 10 points, but getting the user first name is 1 point. And now it's going to get in dynamic. It's going to get in control. I can really understand and set in a very, even you can do this even in directives, start making a little more smart about how do you control how your users are consuming your data. And I love that you're thinking that how we can make this even better. Because you are, right? Yes, yes. So the next thing is let's make it completely dynamically managed. Let's not figure out ourselves how much it costs to make a field, because everything is working fine, everything is, but a developer made a change, and suddenly a specific field is now much more expensive than others. So let's have, using open telemetry and have dynamically assigned weights that constantly are changing, that feeds into the rate limiting, and make sure specific user is not consuming too much information. So changes in the database, even when you change the schema, there's ongoing managed adjustments, let's say. Introspection, spicy. If you have a client server, just disable it. But don't just disable it because that's just, oh, I don't know, I don't want to know. It's too easy still to get your introspection. You can fuzz around it, you can do a lot of stuff. If you are going to do a client server and you care about security, you'll consider persistent queries. During the development cycle, you know what your clients are going to ask. Create those hashed, distribute these hashed to your clients, and it works perfectly. Make sure you're finding a good implementation of operation registry, and just take it from there. Those operations are well-defined. Set as development cycles, super easy, just do it. This is still prone to attacks. Someone can still find that hashed query and send it over and over and over again. So if you want to put this on steroids, because even this you feel like, okay, how do I do this? This is maybe years from now. But you can start having authenticated clients sign that hash. So only signed hashed query will go through. But that depends on your industry. and maybe too early, but just like throwing it out there. If you do have a public GraphQL API, what I strongly recommend is to bring RBAC into your schema. You can call it introspection separation, you can call it schema subset, you can call it, I don't know. Don't keep your introspection open because your users want to explore it, but just be smart about it. Don't kill one of the nice features about GraphQL, the self-exploration. Bring RBAC into the schema. If you're an anonymous user, you can log in. You can see what you're allowed to do. If you're a user, you get to see a little more. If you're an admin, you even get to see a little more. And these things I'll give you 3 ways to think about how you can do it in a very declarative way that is part of your development cycle. 1, directives, super cool. Second, you can define a sub-schema yourself, pair each role. And the third thing, which is kind of a carryover of persistent queries, you have the queries that you think your customers or your roles want to ask. You can you can call it persistent queries plus. You can take them, mash them together, and create a sub-schema. So if you're going to allow your users to ask account information, maybe they only want to ask some subset of that. So you can take all this allowed queries, create a sub-schema out of that, and give that to your users so they now can explore even subset of it. So it really expands what you can do with persistent or allowed queries. And this is how we envision security when it comes to your GraphQL server. Put these controls in front, around, against them. And I don't talk much about PII that can leak because the responses can also have stack traces, can have JSON blurbs, can have error messages with information. Just be aware of what's being returned. Observability, there were many talks about observability. The reason I have it here is because it's just another pitfall of GraphQL when it comes to the existence supporting tools that you might have. You notice most queries will return to 100. Maybe if you did some work, they won't return to 100. But it's very hard for the DevSecOps really to identify between successful calls, regular errors, or the ones that really they care about, which are like authentication errors or rate limiting errors. How do you differentiate between subgraph error to rate limiting? So that is where like this analytics and the ability to have audit trail into the GraphQL usage. And we at Inigo, this is how we think about what it means to have analytics for GraphQL. Ability to understand the shortcoming of the fields, what is taking a lot of time, how do you elevate errors, and go all deep into the path, into the specific query. Because when you need an audit trail, when you get to a point that you are in a compliance and government situation, you need to know who accessed what. Because when an incident happens, someone needs to answer that question. Who accessed what? So aggregation of the data is not enough. What is needed in this case, in this raw data, and I'm not recommending to send everything to Datadog. I'm not interested for you to send me like bills, like this is how much it cost us. No. There's smarter ways to do about it, but just have that in mind. And lastly, when an incident does happen, specifically with GraphQL, you need to know sooner than later. So you need to have to think about turning abnormal GraphQL behavior into actionable, immediate alerts. And how can you connect them to what you're using today? So if there's like many login attempts that has errors in them, maybe now I want to send a Slack message to the team with the proper link so they can explore and investigate when it happens in real time. Because mission critical objects, like purchase order or like payment systems. Those specific errors, when they happen, they need to get elevated to the proper team instantly. So I would leave you with these just questions to go back to your team. Just poke, just ask these questions as in your next GraphQL meeting, engineer meeting. Like when there is an incident, can we answer the question? Who accessed what? What our existing WAF and GraphQL gateway can help us with when it comes to our GraphQL traffic? When there is a change in the schema or in the underlying pipeline of the GraphQL, do we know? Do we know how to vet new mutations? Do we know how to vet new fields that might expose data that by mistake was added to the schema? And I leave it to the last because this is a simple question, which is the fourth question. It's the most simple one, but you will be surprised how much is hard, how many struggle to answer it. What percentage of our API today, of the data that we expose today to the world, is used by GraphQL versus our maybe old legacy or existing REST APIs? So if you're interested to learn more about operability and about security when it comes to GraphQL, you can visit our blog. That's what we do. We write about this. We talk about this. And you can also find us in our booth. We also have a coffee barista, so you can have coffee and talk with us about coffee. That's it. I'll take any questions. I think I have 3 minutes. Okay. Thank you. Thank you for chiming in.